Hi everyone, I am M.Yogadharani, working as Assistant Professor at Department of Computer Science and Engineering at SNS College of Engineering. I am handling IoT subjects. Today we are going to see about fundamental mechanisms and key technologies. In that topic is identification of IoT objects and services. There are various types of identifiers with the different purposes and practicality. So, globally unique identifiers are highly desirable. Identification codes can be classified as objects IDs and communication IDs. So, some of the examples of object IDs include but not limited to radio frequency identification, that is RFID, then EPC, URL. Some of the communication IDs includes media access control address, access network layer IP address, as likewise that. So, identification of IoT objects and service using object ID and network address as it is desirable and all objects to have a permanent unique identifiers, that is object ID. It is also desirable as well as feasible for all endpoint network location and intermediate point network locations to have a durable unique network address, that is NADR. So every object that has a tuple, in the tuple it has an object ID and network address that is always unique, although the second entry of a network address of the tuple may change with the time, location and our situation. However, there is a general trend towards object mobility, that is give rise to dynamic environment and to retain maximal flexibility. It is best to separate in principle that object ID from the network address and thus assign a general object ID and network ID where tuple ID is completely invariant. The basic account of identification scheme is that it offers global uniqueness. Then identification of object ID and service IPv6, it stands for IPv6. Identification scheme is that it offers global uniqueness. It is useful to have mechanism of hierarchical grouping to deal with large population. So the future of IPv6 addresses provides such hierarchical grouping. For a number of applications, there is need to map or bind IP address with the communication IDs and with other relevant object IDs. So, modern layered communication architecture also requires addressing and processing capabilities at several layers. For example, at the data link layer, at network layer, at the transport or protocol ID and the session application layer. With this, some argue that different identification schemes are required for different applications. For example, the information related to things such as books, medicines and clothes may not require global identification because revocation risks are required. So, identification of IoT objects and services based on EFC stands for electronic product code and RFID stands for radio frequency identification. As I already told that an EPC is a electronic product code is a number assigned to an RFID tag representatives for an actual EPC. So each number is coded with the header that is identifying the particular EPC version used for coding the entire EPC number. An EPC manager number is defined, allowing individual companies or organizations to be uniquely identified. An object class number is present, identifying objects used within this organization, such as product type. EPC uses a numerical system for product identification, but its capabilities are much greater. An EPC is actually a number that can be associated with the specific product information such as date of manufacturing, origin and destination of a segment. This provides significant advantages for businesses and consumers. And also EPCs store an RFID tag which transmits data when prompted by a signal by a special reader. that EPC and RFD are not interchangeable. So this is the example for EPC code, and then as I already told that EPC is a number. It holds a header that is 0 to 7 bits, and then followed by EPC manager. It holds 8 to 35 bits, and then followed by object class. It holds 35 to 59 bits, and the last 10 digit numbers are serial number. It holds 60 to 95 bits. So these are some different RFD tags, such as paper tag, EPC tag, key tag, glue tag, metal tag, air tag, ceramic tag, pocket tag, glass tube tag. These are some of the RFD tags. So in this video we see about some of the identification of objects in IoT. In next video we see about more identification of objects and its services. Thank you.